Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're gonna talk about NVMe SSD NAS, which are flooding the market as of now. So let's dive deep into it. So why do we need these things? Well, we have to need it simply because data is becoming more and more and more important. And more people are actually realizing that data is freaking important. So that's here. And it also applies on individual plus business. So it's not something that you can just like, no. It is something that you have to give a damn about. And local data storage is the best. Now you're like, why? Well, factually speaking, if you have your data on the cloud and you can get to it, fundamentally, by the laws of physics, other people can also get in. For example, Department of Justice, they literally were creating basically FBI watch list simply because they got hacked. So let that sink in. If you put your things where you can get it, other people can also get it. That's why, like, whenever a moat was created, like a castle that is surrounded by water, it always had only one door. Because again, yes, you are limited by one input and output, but that also means enemy is also limited by one output. But if you're like, hey, what if I have like four sides and it's no longer a moat? So it's one of those things that you have to understand. Put data somewhere where it's easy to get to. Fundamentally, it's easy to get to. And whenever you are talking about actual hardware, you are talking about no recurring payment. That is a very desirable thing for many places, especially for business that are just starting out. Let's say I'm working on a startup company. We may have a budget or we may have got investor, but does not mean every month we're going to keep getting it, or our revenue stream would be that stable. So in those are time, risking your data because you're like, oops, I missed a payment, or like you had a issue, all your data, poof, gone. And then we come to the bitter part, privacy. Nobody gives a damn about privacy, especially in their cloud business. So anything you are storing in cloud, even if you encrypt it, unless you are double encrypted and with really strong system, companies will be like, I can guarantee you, they will look into it. Guarantee you that. They generally don't do anything with it, but they look into it. Like Tim, there is a journalist who showed, like, if you drag dropped a specific type of file, type as in like with some journalist file, known media file and all that, if you just drop the file, Google deleted it. And it's not a unique thing, it's done everywhere. So it's one of those things that if you value your privacy, you have to know this part, that data is only secure with you. Then we come to the two things that we need, like, to make this experience manageable, is redundancy and speed. If you do not have redundancy, this will be your data. Unless you are storing all your data like this, which I'm doing now, basically porting everything in my single layer DVD. Dual layer DVDs are super expensive. So like, I'm burning everything that is important to me onto these things. Anything that is super important, I'm burning into M disk Blu-ray. So that thing is physically passively safe. So it will be there no matter what, unless, like in this sort of case, I burn it or humidity gets to it. So it's generally safe for long term, but again, very limited storage capacity. Like the Blu-ray price, single layer Blu-ray is same price as dual layer DVD. I'm like, what the hell? So it's one of those things that you have to understand, that redundancy and speed is compulsory. If you do not have redundancy and you are like, hey, I stored all my data on a NAS, if I'm safe. Yeah, no, not really. Like, for example, Linus Tech Tips, they suffered an issue where they were not doing checksum calculations, or what we call scrubbing. Basically, every byte of data is actually checked and studied, and like, hey, are you all right? This is how you're supposed to be. Checksum data allows you to check that, and it also allows you to figure out which is the corrupted data, so you do not mix up things. They did not do that, and voila, all their server poof. And another YouTuber, basically, he's a photographer and a very big successful YouTube channel. You may have heard of him. It's like now I forgot his name, Tony Northrup. And he was also like, I recently wanted to collect all the photos of my daughter, and there is like all the files were like this. Why? Bit rot. Now why the heck that happened? Because it was not redundant, meaning the file was there, but it was not being scrubbed periodically. If you do not scrub your data is as good as gone. Over time, it will go away unless you use this. And now you understand why I have this. So it's one of those things that you have to understand. So redundancy, speed, these are the key. Otherwise, we'll not be able to do it. So what were the market forces that are playing the game here? Well, you have to understand, these puppies, as in like the mechanical hard drive, these puppies, they are reaching end of life, meaning the amount of R&D money going into them, they are now being phased out. Why? Because they can have capacity, meaning this puppy is a tiny puppy of 2 terabyte. You can, if you have money, serious money, you can go up to 20 terabyte. But here's the deal. While you can pay for that much capacity, you will get that much capacity, you will not get the speed increase. For example, this puppy can give you around 250 Mbps. The is super duper large capacity one still will only give you that much. You'll be really lucky if you can sustain 300 and all that. So realistically, the speed has not increased in sync, meaning we should be at Gbps if you are talking about 20 terabytes, but we are not there. So that creates a paradoxical effect, meaning let's say you have a server, everything is fine, everything is dandy, you have 20 terabytes hard drives, and let's say you have 8 of them, and you have dual redundancy, meaning if 2 hard drive goes, you only then you lose data. You're like, okay, one hard drive, poof. What will you do? You remove it, put a new one in. Awesome, that's how you're supposed to do. But here's the problem. Now the computer will try to write parity data back, so it again gets back to what we call from degraded state to stable state. Now here's the deal. That process will take time. Why? Because the tank is huge. Tank is 20 terabyte. Now the throttle, basically the throat, is very limited. You are only dumping data at basically 250 Mbps, and this is the danger part, meaning to calculate that parity data, computer has to read all the drives. The moment it will put that kind of strain for that duration, meaning sometimes it could take a week to a month, and I'm not exaggerating, that's how long it takes many times. All your hard drives are working flat out, meaning now you're in danger of, while you're trying to rebuild your array, you could like multiple hard drives could fail. And yes, it has happened to more than enough people. That's why people are jumping into SSD, and I'm talking about enterprise grade. People have learned it the hard way that hard drives, if they have ludicrously large capacity and they do not have in and out that is fast enough, it's basically a tragedy waiting to happen. So what are the speed categories? There are 3 speed categories that you're talking about. So first category is these puppies, that is around 250 Mbps, give or take some here and there. So they do not even cross SATA 3. Then you have these puppy, basically 2.5 inch SSD SATA. Now these puppy do reach a saturation point of basically 550 Mbps to 600 Mbps. Now I'm old enough where even this speed was not achieved. We had SATA 3, but these things were not actually able to hit that sort of speed. So we were like very happy if you got something that was actually able to do around, let's say, 300 Mbps, 400, like whoa, 500, whoa, 550, damn. And most of the time write speed was horrible, but now in modern times write speed is actually good. So we have finally reached a point where SATA 3 is the bottom limit. And these puppy can actually go faster, but the connection speed is like, nah, the link bandwidth is the limiting factor. So then we have the new puppy. The new puppy is NVMe. Now, NVMe is fast. It's the flat out the reason why SATA 3 is like, bye-bye, I'm done. SATA 3 is like, this cannot go on anymore. It's like, I'm done, end of the line, so it's done. NVMe is the backbone tech, meaning it's no longer just like, oh, your laptops have this. No, no. Not only your laptop, your desktop, your servers have this. So it has reached a point where it's actually viable and practical and safer for people to put their data into these puppies. So it's here, it's real, it's happening. And prices are coming down. I had paid like 10,000, just pay attention to the number, 10,000 rupees to get something of this size, physical size, 120 basically gig SSD for this sort of speed, 500. Now, if I pay that amount of money in basically today's time, be mindful, inflation had made it even more weaker, but even the number remains the same. 10,000 I paid for 120 gigabytes of Samsung, I think 670 or 870 Pro, Samsung Pro. Now I can spend that kind of money and get these things that will be at least 1 terabyte and it will be exponentially faster. So prices are coming down for you and I, not only for enterprises, actually coming down. And I have lived through all these 3 iteration, meaning this, and NVMe. So I know that prices are coming down. Right now, you cannot actually buy very large capacity of these. These are being phased out. There's no point of making them, because be mindful, NAND flash was the weak link early days. Now it has crossed that point. So they're like, what's the point of making this? So everybody is going this. And even the low grade one, it can easily give you 1 Gbps of read and write easily. Quality one, like I have this one, Samsung 990 Pro, that puppy gives you 7.5 Gbps read speed. Write speed is still 4.6 gigabits per second, bytes per second. So it's bonkers what kind of speed that we can get nowadays. So this is the market forces that are creating a world where we have to use these rather than these things. So what about devices? Now be mindful, enterprise, they had their puppy. So we had talking about QNAP TBS6 464. Who came up with this name? Anyway, this is I think Mark II product and all that. But it's like a small device. It's not targeted for like ball to the walls kind of individual, but it's like more of a home user or small startup and those sort of thing. It has like 4 NVMe slots, and it can give you like, basically 2 into 2.5 gig LAN. Now you're like, why the heck we are still stuck at 2.5? Well, 10 Gbps was tried with Ethernet. That was the biggest mistake. 10 Gbps should have been forced to optical. Nobody did that, and that's why we are stuck in this awkward position. Even though 10 Gbps is older than 2.5 Gbps, older than 5 Gbps, but because it was using same cable was the weak link, and it never actually succeeded. So 10 Gbps is still only used for professional, and most of the time enterprise grade they directly jump to optical, and then they directly jump to 2.25 Gbps optical benefit. So this is the awkward part, where it's like we don't actually have a good middle ground. Either you stay in Ethernet and have weird things, or just jump to optical. So it gives you 2.5 Gbps. Now be mindful, because it's NVMe, it does have a competent enough processor that you can actually do enough of a live video editing on one system. If you have very high bitrate video files, you can do that quite reliably and safely, and you can be secure, you can be safe in knowledge that if one of the NVMe says poof, you are still like safe. And be mindful, these are NVMe, so if you remove it, put a new one in, it will be rebuilt very quickly, as in matter of hours rather than days, weeks or month. So that's the good part. Then we have Flashstor from 6 series. This puppy is like this one. I think this is a 12 variant one, but you have two variants of them, 6 NVMe slots and 12 NVMe slots. Those are available, and most of them can easily service you more than 100 Mbps read and write. Now be mindful, that may not sound so amazing. We are talking about NVMe, and even these puppy can give you that, but here's the deal: when you're talking about multiple drives, you also have to do some calculations and throughputs, and there is so many layers that having, close your eyes and you're going to get this sort of speed in a small package that you can put on your desktop or even carry in backpacks. Yeah, that was unheard of. So fundamentally, that's really good, especially in the write operation, because you have to do parity calculation. So 100 Mbps plus is easily achievable. 200 Mbps plus is easily achievable. That's why all of them comes with 2.5 Gbps. 500 as in like 5 Gbps connection. Yeah, that's difficult. Basically 10 Gbps. Problem is that 10 Gbps, other things become a bottleneck. So you're not gonna get that wow performance that you would have expected. But it does come with one nice benefit. Benefit is extremely low power draw, meaning none of these puppy can even cross 100 watts of power draw, and I'm talking from plug. I do not like that they have like power bricks outside. I do not like power bricks. I always want my power brick to be integrated. Like I can't have these two things separated. Like I have to have a AC power, I have to have a power brick, then I have to send it. Why don't you just integrate it? I don't really don't like one box plus one baby box plus another thing. No, just plug, box. So all that still can be done in less than 100 MB, basically 100 watts of power while you're running it at full load. So it's a really, really low power, and benefit of that, really quiet cooling solutions. So what more performance we are expecting? Now this is where I have to bring you down to the ground. Yes, on paper, and each NVMe can go YOLO. Like if you have a quality NVMEs, they can go YOLO. They can go balls to the wall, around 500, basically 5,000 megabytes per second read and write easily. But you're not gonna get this. You have to understand this aspect very thoroughly, is that just because you have ports, just because those are quote unquote connected, does not mean they can give you full throughput. For example, let's say you have 8 NVMe on one PCI card and you have 16x. Now it looks good, looks competent. Yes, each of these puppy will consume 4 slots. You only have 16. 4, 8, 4, 8, 8, 8, 16. Sir, what about those? That's the problem. Just because you can connect it does not mean you can get ultra, super, hyper throughput. This will be, in this scenario, this will be limited by 16x slot limit. So you have to understand this. And parity data calculation is not an easy task. Like even if you are doing, let's say, ZFS file structure, it will take some serious compute power. Not too much. Let that be very clear. Not too much. And be mindful, these things can actually help your CPU, because it will not be like, oh, my CPU is requesting this data block. My hard drive is like, let me spin up, let my head go there and random file. No. The random read and write is exponentially helpful in this scenario. So if you have a good RAM buffer and these things are working at as they should, they will dump enough data fast enough that CPU can actually crunch fast. And if your CPUs have like enough horsepower, then you can do parity calculation very high speed and actually achieve throughput of 1 gigabyte per second, meaning you can saturate 10 gigabit link reliably. So be mindful, parity calculation does take some serious horsepower. We are not talking about like, quad core atom processors. No. Like it can do it, but do not expect 10 Gbps kind of performance. And another aspect is low cost CPUs. The biggest difference between let's say 24 core desktop processor versus a 24 core server processor would be one thing: PCI lanes. How many lanes these puppy have? CPUs require PCI lane to operate. Everything consumes PCI lane nowadays. Heck, even your network requires PCI lane, especially if you are talking about 10 Gbps. So all of these consume lanes, and your CPU has limited amount of them, and that's the biggest bottleneck. That's why these things, even though they are quite competent, quite good, they are not like enterprise grade. It may look like it may feel like it, and the companies are marketing it like that, but it's not that. It's simply because, bro, you don't have the processor power there. Even though connection speed may be like, hey, pipe is like, empty, the processor won't be like, I can't crunch it fast enough. And if you have basically NVMEs, it's like, bro, I don't have enough lanes. Some of these have CPUs that have only 8 lanes, and they have 6 NVMe slots. Fundamentally, it cannot do. So that's the whole point. And if they're like, hey, I'm going to give you 10 Gbps connection output, that fundamentally, that itself will consume minimum 4 PCI lanes. So you have to understand, they have to split it. Just because these are connected does not mean they give you the same oomph if they were like actually truly connected. Which, again, that's the reason why enterprise grades are super duper hyper expensive, and they reach a point where it's like, if you have to ask the price, you can't afford it. So that's the performance. So what we can expect in the future? Well, this is one thing that I'm really happy to see, simply because these sort of small things, while they may look niche and all that, they are more balanced. Meaning, yeah, everybody's like, I want this and I want that. Do you actually need it? Like, do you actually need it? Like, you can literally have, if you are having a NAS box that is running on NVMe, that is competently built by any of these brands, you can do 4K live video editing on multiple systems, easily 4 or 5 systems. Meaning, if you are like, let's say, a wedding shooter kind of guy, and you are like, you have a crew that is doing all wedding, and all of them themselves are doing video editing, you can be like, bro, I got this. All the file are dumped into the NAS keeps it safe and secure, and then you edit from it. You're good. You're good. Like, yeah, you like, what if I have a red cinema camera? If you have a red cinema camera, you can afford a goddamn proper enterprise grade server. So it's one of those things that, like, yeah, we want it, but it's like, do we really? So these sort of approach that somebody in the marketing department is like, hey, just put things there, so people are like, nice shiny things, and it should not act as a bottleneck, but it's not two balls to the walls. It's not like putting a server grade CPU which cost will go up. So it's a really balanced kind of approach, and it's a really useful for most amount of people, even from like a small business, startups, to heavy enthusiast and all that jazz. You can take care of a lot of them. Now, DIY option will take time. Right now, you can make a good DIY NAS server from this thing, and it will be cost effective and competitive also. Meaning, you will get better performance, better everything if you directly build it, especially if you are building with multiple hard drives. The power efficiency is only there if you are building like 4 drive system. If you are building like a very large system, you will find these things to be more energy efficient. So that part is taken care of. However, the moment you go to NVMe, yeah, that's an issue. That's a very serious issue. And this also exposes the one of the weird limitation is that operating system of network attached storage is not a child's play. Meaning, most operating systems do not have something like ZFS, where they actually do parity calculation regularly enough, and where they have so many fail-safe built into it that, yes, the hard drive is there, the data is there, that means data is there. It's not like, oh, the images files are there, and you try to open it up, it's like all corrupted. That requires something like ZFS, and very few of them actually have it. And can you build a NAS box yourself that has those sort of redundancy? Absolutely. You have to know what you are looking for. So from an average user point of view, that's not viable. Linus Tetus is claiming that he's working with a company just to make a operating system that is free and open source, but with one caveat, that it's actually plug and play, and it has taken care of all the heavy lifting, so to say. But until that point, that becomes a normal thing. That's a difficult thing. Now, let's say you can solve it. Let's say you are a guy who can actually follow technical guides very competently. Good, but still limits by PCI splitters. PCI splitters are not something that is sold to common public. There is very low chance that your motherboard actually has one. But in server industry, that's how it works. Even though server industry physically have so many PCI lane, they still amplify them to, like, twice, 4 times, 8 times. I'm not joking. They actually have sometimes that one PCI lane is multiplied by 8. You're like, would that actually be useful? Actually, yes. If you are talking about PCI 5.0, and then you split it that many times, you still have more than enough oomph, where it's like, more than good enough, more than good enough. So Those things are difficult, and be mindful when I talked about that Asustor system that has like 12 NVMe. It has the processor only has like 8 slots, 8 PCI slots. I'm like, how? What? So be mindful. That part is the hard part. That part is not something that you can just control C, control V. That's a difficult part. It's not common publicly. It is available. It's a thing, but it's not common. And so DIY at this point in time will neither be cheap or efficient at this point. So right now we are in the zone where only buy is an option, viable option. And you can buy them. Right now, the price in India is like for a 4-slot system is around 80,000 rupees, which is expensive. I'm not going to say it's cheap, but doable. And again, even though these things have not become as cheap as this thing yet, but they will become that, because once manufacturing of these starts to slow down, they will go up in price. And once these reach mass production, as in like they are already reaching mass production, but they are reaching mass production for heavy loads, where it's like 4 terabyte, 8 terabytes. That's like good, but like consumer cannot touch it. But like once they start to come down to like 2 terabytes, especially 4 terabyte, which is available in P3 size, you can get like 4 terabytes. Once those start to being mass produced as base rather than 1 terabyte, right now that's the base. Once 4 terabyte becomes the base, price will come down enough where it was like good. So even though right now you can buy it and only populate it with 1 terabyte SSD sticks, in future you can easily upgrade to 4. So that will be awesome. So it's a really good ecosystem that we are developing, and I really like it. I just hope somebody can figure out how to sort that PCI splitter part. Then we're gonna have some good DIY systems. So this was my presentation on basically the NVMe SSD storage solutions that we are dealing with right now. And CES had some new options which I have linked down below. So this was my presentation on those topics. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.